let's say you had a function which looks like this, where you have x and y both on one side. And in a scenario like this, you don't immediately have a subject, right? So neither y nor x are subjects of your formula. Making it the subject, so making either x or y the subject, is just going to be complicated and it's just going to be long. So what you can do instead is use implicit differentiation. In this case, here's what we're going to do. We're going to differentiate each term separately, but there are certain rules to it. The first term is just an x. If you differentiated x squared, what would you get? 2x. Nice and easy. We move on to the next one. If you differentiated y to the power of 4, what would you get? 4y cubed. And there's a plus in between them. Because you are differentiating the y term, in implicit differentiation, when you differentiate the y term, you add dy by dx after, like this. You don't have to do it when differentiating the x term, only with a y term. So you differentiate it, and then you add dy by dx next to it. Okay, in something like this, you have x multiplied by y. Here's what you do. You would get x dy by dx plus y. That's what you get when you implicitly differentiate an x multiplied by y type of term. Okay, when you differentiate 3, you end up with 0. From this point, all you have to do is rearrange that function. So from here, you have to rearrange it to make dy by dx your subject. That's implicit differentiation. So let me go through this example, then you're going to do 2 on your own. So we're going to take each term step by step. For this, you're going to take each term step by step. What do you get when you differentiate x cubed? 3x squared. What do you get when you differentiate x? 1. And there's a plus in between them. What do you get when you differentiate y cubed? 3y squared. But since we're differentiating a y term, you're going to add dy by dx after that. So what do you get when you differentiate implicitly 3y? Plus 3 dy by dx. And then differentiating 6 gives you 0. Now, can you rearrange all of this for dy by dx? So you would get 3y squared plus 3 dy by dx equals minus 3x squared minus 1, and then you divide. Done. You can even take it a step further by factorizing the 3 out from there. Like that. That would be your fully simplified answer. That is implicit differentiation. That being said, can you try that question for me, please? So for the first one, you have an x and y term together. So if you remember, the rule was x dy by dx plus y. Okay? So your x is 4x. You're going to multiply that by dy by dx, which would be 2y dy by dx plus your y term, 4y squared. Okay? Then plus your second term is 6x squared over y. What you want to do here is rewrite this as 6x squared y to the power of minus 1, and then you can use the product rule. After using the product rule, you should get 12x over y minus 6x squared over y squared dy by dx equals 0. Okay, you have your coordinates, x equals 1 and y equals 1. You're going to plug those in. After plugging those in, you should get 8 dy by dx plus 4 plus 12 minus 6 dy by dx equals 0. 16 plus 2 dy by dx equals 0. So that means dy by dx equals minus 8. There you go. Done. You're going to have to make use of the chain and product rule also whilst doing implicit differentiation. It's not easy. Implicit is going to take a while. It is going to take some time to, understand. So I would suggest try to do as many questions as you can, and don't forget you can ask me if you need help. There's a button where you can fill out a form. You can ask your question. You can put in your picture of your work, and I will mark it and I will get back to you. So even if you don't get it, if you seem to be getting it wrong, I will mark it. I will help you. I'm going to help. Question 7. If you feel up to it, if you feel ready, can you give this one a go for me, please? So with this one, we're going to do the same thing as before. You're going to differentiate each term separately. Differentiating 2x squared gives 4x. Differentiating 3y squared implicitly gives 6y dy by dx. Differentiating minus x gives minus 1. And then differentiating 6xy, you can write it as 6 bracket xy. So it would be 6 bracket x dy by dx plus y, making use of that rule. And then differentiating 5 gives you 0, and it's equal to 0. Like that. Cool. Now it's a matter of rearranging to make dy by dx the subject of the formula. So 6y plus 6x dy by dx equals 1 minus 6y minus 4x. So expand this bracket and then move everything that doesn't involve dy by dx all to the other side. Okay, so that means dy by dx is 1 minus 6y minus 4x all over 6y plus 6x. You have the coordinates x equals 1, y equals minus 2. When you plug that in, dy by dx equals minus 3 over 2. That is the gradient of your tangent also. There's no minus reciprocal rule, that's only with the normal. So when you have the coordinates 1 and minus 2, you're going to do y minus y1 equals mx minus x1, where this is your x1, this is your y1, that's your m. So at the very end, you should have 3x plus 2y plus 1 equals 0. Done. Implicit differentiation.